Hey there, welcome to the Accurate Physics. Today I'm going to talk about Big Bang Theory, the origin of the universe, and evidences behind this theory. What are the proofs of this theory? So before starting, if you haven't subscribed to this channel, please subscribe right away. So to get started, I will talk about the important personalities who contributed to form this theory, which is we call now Big Bang Theory. The first name was George Lemaitre. He actually put forward the concept of Big Bang. Actually, he didn't coin this word, the Big Bang, but in 1930, he explained how this universe was evolved. According to him, our universe evolved from an extremely dense and hot state, and space has been expanding ever since. So, from some hot and dense state of the material, there is some kind of bang. It's not word selected by him. Later on, somebody else coined this word. I will talk about that. And next person who find the proof of Big Bang, that is the expanding universe, is Hubble, Edwin Hubble. In 1920, Edwin Hubble put forward his law, which we call Hubble's law. I will talk about it a little bit later. Uh, he observed the expanding universe. From his observation from the telescope, you might be familiar with the Hubble's telescope, right? Which is one of the biggest telescope, Earth-based telescope, uh, visible light-based telescope in the planet. And from his observation, he found that universe is expanding. I'll be talking about expanding universe later, and the topic when I talked about the evidences of the Big Bang Theory. Third name who coined the origin of the universe, the named as a Big Bang, is Fred Hoyle. He coined this word Big Bang in 1949. And another renowned physicist, astronomer, Stephen Hawking, calculated that if the rate of the universe's expansion just 1 second after the Big Bang had been slightly slower by only 1 part in 100,000 million, the universe would have collapsed back on itself, making the evolution of intelligent life impossible. So this is also another proof. He actually calculated the rate of the universe's expansion. And if this rate is a little slower, he has given data right here, right? It's only 1 part in 100,000 million times. Then it would be collapsed. It would have collapsed back on itself, making the evolution impossible. All kinds of things that we can see now, all these galaxies, stars, planets, and intelligence life could not be possible. So these are scientists who put efforts to coin the word to describe how this universe came into existence. Now, main point is, what are the evidences that supports the Big Bang? Is this reality? Sometime about 13.7 billion years ago, there was a boom like Big Bang, and everything came out of it. What is the evidence? How can we believe it? It's not a matter of believing it, right? There should be scientific evidence so that we can say for sure this universe is in existence because of Big Bang. Today, I'm gonna talk about those evidences. You might have heard about Big Bang, right? But you might not know what are the evidences. I'm telling you 5 proved evidences, scientifically proved evidences in this video. Please keep watching this video until the end of the video. Okay, the first and most important evidence is cosmic microwave background radiation, CMB. I'll be talking a little bit more about cosmic microwave background radiation, what it is, and how we can say for sure this is the proof of Big Bang theory later. And second proof is the Hubble's law and the expansion of the universe from the observation, scientific observation using his telescope. Hubble proved that a kind of law. I will also discuss about it later. And he found that this universe is expanding ever since. And another evidence is abundance of light elements. And the fourth one, redshift of the galaxies. And the last evidence is large scale structures of the universe. So these are most important high evidences, proofs that supports the Big Bang theory. And remember, these are scientifically proved. So what is cosmic microwave background radiation, CMB? This is one of the most compelling piece of evidence for the Big Bang theory is the existence of cosmic microwave background radiation is compelling, and it was supposed that the cosmic microwave background radiation was originated at the time of Big Bang, and it was discovered in 1965 by Arno Penzias and Robert Wilson. And actually, what is cosmic microwave background radiation? This is a pentaglow of radiation, a kind of radiation that fills the entire universe in all directions. It is isotropic. That means the properties of cosmic wave radiation is same throughout the universe. It's the same in all direction, and it's uniform. So its existence should be from the beginning of the universe, which is the Big Bang. It is considered the afterglow of the hot, dense early universe, and it provides strong supports for the idea that the universe was once in a hot, dense state. Because right now, when you measure the temperature of cosmic microwave background radiation, its temperature is very, very low. It's about 13.7 billions that has been passed. That's why it's cooled down significantly. Right now, the temperature of cosmic microwave background radiation is about 2.7 Kelvin. You know, Kelvin is very, 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 very low temperature. 2.7 degrees actually in Kelvin, I mean, is really, really low temperature. So from this evidence that was discovered in 1965, we can say the universe started from the Big Bang. The second evidence was given by Hubble's law and the expansion of the universe. Because Hubble's law tells us about the expansion of the universe. Edwin Hubble in 1920s, he discovered that the galaxies, all the matters in the universe is moving away from each other. The expansion of this universe is not something like the blast of bomb, atomic bomb, or something blasting. It's not something like that. It's like as if you have some black dots or some kind of dots on a balloon, and you are blowing up that balloon. As balloon expand, the distance between the dark spots or whatever the color of the spot there is, they are moving away from each other. It's that kind of expansion. So from his observation in 1920, Edwin Hubble observed these phenomena that galaxies are going away from each other. This observation is called Hubble's law. It's given in the right, you can see here. It suggests that the universe is expanding. The expansion of the universe is a fundamental prediction of the Big Bang theory because, at beginning, according to the consideration of Big Bang theory, it was very hot and dense condition, like we call it like singularity, right? So it's expanding. If you find the evidence of expansion, then it means it should be some time long ago, about 13.7 billion years ago. It should be very dense. And at the same time, it should be hot. Right here, we have equation. It was given by Hubble, and Hubble given this statement, this equation, which is the which we call Hubble's law. Left hand side of this equation is velocity or speed. We call it receding speed of the galaxies or stars, whatever we can say, the material as a whole. And on the right hand side, there is a Hubble constant, S naught, capital S naught, and the distance between the galaxies. So according to this equation, we can easily see the speed is directly proportional to the distance. The farther the galaxies are, more rapidly they are expanding. That means they are going away from each other. The another evidence of the Big Bang theory is abundance of light elements. What do you mean by light elements? If you look at the periodic table, there are so many elements listed. At least 92 elements are listed in the periodic table. Natural elements, I mean. So light elements are like hydrogen, helium. Hydrogen is the lightest one, then helium, lithium, and so on. If you observe the universe, you can see this universe is full of stars. And also the materials in the environment. There is plenty of materials that is made out of light elements. So which was formed in the early universe through the nucleosynthesis. That's why, look at the sun right here in this figure. What is consumed material of this sun? And all the other stars in the universe. There are billions of stars in the universe, right? All the stars are made out of light elements, something like hydrogen, helium, and so on. That's why this tells you light element is abundance, and these kind of elements were formed by nucleosynthesis at the very beginning of the Big Bang, after the Big Bang, right? So this is the another prediction. And the third one, and also is most important, I think, is the redshift that actually measures the expanding universe, right? Expanding galaxies, right? Like redshift of the galaxies. If you observe the light coming from the distant galaxies, you can see there is the shift in wavelength or frequency, which we call redshift. The frequency and the wavelength is shifting towards the red light. This is the proof found by Hubble, which we call redshift, right? The light from distant galaxies is redshifted, meaning that the meaning of redshift is that the wavelength of light are stretched as the galaxies move away from us. It means the wavelength is decreasing here. See the top? When the star from the distant galaxy is going away, the wavelength of this light is stretching and frequency is decreasing, right? If it's opposite the case, if universe is contracting, what should happen? It should be belief shifted. But according to the evidence that we observed, the universe is expanding because we can observe all the time the redshift. So this is crucial evidence. Okay, the last evidence is large scale structure of the universe. We can see the sometimes, in general, microwave background radiation is uniform in all directions, but there are few points where it's not uniform, where there are galaxies and huge mass is accumulated over there. In those points, these large structures like galaxies, the distribution of galaxy clusters, can explain why in some particular points the microwave background radiation is not uniform. So from all of these evidences, we can say for sure the existence of universe is because of Big Bang theory. It came out of this world, this universe came out of the Big Bang.